So greetings of the day. Welcome to the course on Operations Research Technique. In last lecture we have seen the calculations involved in PERT problem. In that problem we have also seen what are the contents given, what are the various data set given. Based on data set we analyze various parameters, and now we will move ahead from the point where we have ended our last lecture. If you recall, in last lecture we have drawn network, we have calculated activity times from 3 time estimates TO, TM, TP, and we have mentioned over that network symbolic representation of various location of the parameters and formulas for forward and backward calculation. And if you recall my last lecture, I have said that any network, any project will start at 0th point of time, maybe units, maybe in days, maybe weeks, maybe month. So earliest start time for any project for that matter will be 0. So now let's move from our last discussion ahead. So focus your attention on calculation of these various values. Now TEJ is in forward pass, this TLI is in backward pass. TE, I have explained the meaning of TE, E earliest and T time. TL, L latest and T time. So earliest time, latest time. Let's start. Now this is beginning event, event number 1. Earliest start for this event will be definitely 0 time. So always put in this corner left hand location where we are mentioning TE as 0. Now first what we will do, we will find values of this particular location T for all events in forward pass by this formula, and wherever we get more than one value we will select maximum values. Let's move how we go. This is TE of previous plus activity time of current activity under consideration. Now if I want to find this TE for event number 2, this location TE, this is I, this is J, TEJ is equal to maximum of TEI, TEI is 2, TEI is 0, TEIJ is 2, so 0 plus 2 is 2. Got it? Yes or no? In forward pass we will be filling these locations first. What value I shall write here? I should write here 0 plus 4, 4. Got it? What should be the value over here, students? 0 plus 3, 3. Be sure for the location. Can you write value directly over here? 3 plus 5, 8. No, that will be wrong, because this is only one value you are getting of 3 plus 5, 8. You have other values. Unless and until you find both values and compare and select maximum, you cannot write directly. So wait. Now 2 plus 1, here one value is 3 for me, and 4 plus 6, other value is 4 plus 6, 10. So for this 5 event I am having two values, 3 and 10. Which value I should write? By this route I get 3, by this route I get 10. Which value I should write? Maximum of 3, 10. 3 and 10, maximum 10. Write 10. Got it? Very important. Now, here you will be getting two values. 10 plus 7, one value is 17. 3 plus 5, 8. Two values. One is 8, other is 17. Which is maximum? 17. So write 17. Students, this is forward pass calculation. This is forward pass calculation. Now we'll go for backward pass. And now earliest, the meaning of this is this particular project consisting of 7 activities will be completed earliest in 17 weeks. That is the inference right now. As a project manager, if I know my project is going to be completed earliest in 17 weeks, so naturally latest completion I will expect for my project under my leadership in 17 weeks only. That is very, very important. So, considering this logic, this statement, latest completion will be 17 weeks. So, whenever latest scheduled completion is not mentioned in the problem, whenever scheduled completion of the project is not given in the problem, scheduled completion period of the project is not given in the problem, without any hesitation, put earliest completion time as latest completion time. Very, very important point. If it is given latest completion of the project is 20 weeks, suppose it is mentioned in the problem, then I have to put here 20. Since nothing is mentioned, without hesitation put earliest expected time as latest completion time. And now backward pass, reverse calculation. Wherever in forward pass there were arrows, but in reverse pass there will be tails, tail of the activity. Now what is the formula? Now this value is T, this location is TL, this location is TL, TL of J, this value 17 is TL of J. I want TL of I, means earliest event, this is I, J. So I know TL of J 17. For getting this TL of I, TL of J 17 minus TEIJ. So 17 minus 7, how much? 10. No question of minimum, only one arrow, only one tail. Got it? J, I, J. Similarly, for this ith event, TL of J is 17 minus TEIJ is 5. 17 minus 5, here I will write 12. Got it? Now backward, we are moving backward. 10 minus 6, 10 minus 6, 4. 10 minus 1, 9. Now students, here you are ready with these three values and three tails are terminating here. So you will get three values. You will get three values. Of three values, you will say minimum value. You will select minimum value. So which are the three values? 9 minus 2, 9 minus 2, 7, one value. 4 minus 4, 0. So 7, 0, and 12 minus 3. So the values which I get here, I will write 9 minus 2, 7, 4 minus 4, 0, 12 minus 3, 9. So among these three values, this is minimum. So I will write 0 over here. Now I am ready with all these calculations. Now my task is to find the value of slack. What is slack? Difference of TL and TE. 0 minus 0, 0. Intentionally I am using different colors for understanding purpose. 9 minus 2, 7. 4 minus 4, 0. 12 minus 3, 9. 10 minus 10, 0. 17 minus 17, 0. Very important now. All calculations are ready. See, by writing these formulas, I have saved lot of labor in writing lengthy equations and finding the values. Now one who want to interpret will only interpret from this symbol and this formulae, that okay, the calculation was based on this particular concept. This is TEJ and TLI. He has already given the logic how he has find these values. Important now, critical path. Again I will define that. Critical path is the path of longest duration on the network and values of slack for critical path is 0. The path of longest duration on the network on which value of slack is 0, that is critical path. So what we will do now, we will joining the activities on the network, we will join the activities of the drawn network with 0 slack, which is responsible for making that path as a longest path. Very important statement I am quoting. Only join those activities with 0 slack which make the path longest path, and represent critical path by either solid line or by double line to identify the critical path from different paths. How, that I will explain. Now here see, this is slack 0, this is 7, 0, 9. So 0 to 0, 0 to 0, join this activity. Again 0, 0. What I am doing? I am joining activities with of 0 slack with next 0 slack. 0, 0, 0 slack, 0 slack. So students, now the network representation has changed. We have identified one path as a critical path. One path as a critical path, and that path is 1. Why it is critical path? It is the path of longest duration of 17 weeks on which value of slack is 0. So to reach these 17 weeks, we need this path with 0 slack on these events, and activity 1-3, activity 3-5 and activity 5-6 will be referred as critical activity. So now what we'll do, we'll see what was asked in the problem and accordingly we'll answer each and every question. So if you recall the problem, first was what was asked is, first was draw network, that is we have drawn. Second was identify all paths of the network. So what do you mean by all paths are? First path is 1, 2, 5, 6. 1, 2, 5, 6 is first path. Meaning of all path is to reach from starting to end. Our starting is 1, end is 6. So to reach from 1 to 6, I am having 1, 2, 5, 6. Second is 1, 3, 5, 6, and here I will write special, it is critical path. It is critical path. Got it? Third, 1, 4, 6. So this is the answer for bit number 2. Now third. What is third? What is expected project duration? So students, expected project duration is equal to your last answer, that is 17 weeks. Systematically, how you are supposed to interpret your observations, your calculations as per demand of the problem. So these 3 parameters were asked, and this whatever your last value after you get critical path, that is TE is expected project duration. Do not forget to mention the units of expected project duration. Never forget. Now, with this background, See here, we have done this exercise. Now once we did this exercise, further part was asked to find the probability of completing the project. If you recall, I know the problem. 4 weeks earlier than expected time. What is expected time after calculation in this particular network? It is 17 weeks. What do you mean by 4 weeks earlier than expected time? Simple. In previous lecture, I have mentioned x minus. X is expected project duration. So here, my expected project duration is 12 weeks. 17 weeks. 17 minus 4, 13 weeks. So what is asked? Find the probability of completing the project in 13 weeks. First bit. Second bit was asked, not more than 4 weeks than expected. Not more than. Expected is 17 weeks. Not more than 4 weeks. 17 plus 4, 21 weeks. 17 plus 4, 21 weeks. So students, first is 13 weeks, we have to find probability. Second, 21 weeks, we want to find probability. Third one, during expected duration. During expected duration meaning during 17 weeks. So what is asked in this problem is, we are supposed to find probability of completing the project within 13 weeks, then 21 weeks and 17 weeks. Now, simple logic. Suppose one project takes 10 weeks and somebody is asking me to find, normally it takes 10 weeks, and somebody is asking me to find what is the probability of completing that project less than 10 weeks. Maybe 8 weeks, maybe 7 weeks. So students, the probability of completing any project before its expected time will be lower side, will be on lower side, less than 50%. And whereas if somebody is asking me, okay, your work, your project takes 10 weeks, what is the probability that it will be completed in 20 weeks? Yes, it's very natural that the task which can be completed in 10 weeks, if somebody is asking 20 weeks, probability of completion will be on higher side, approaching towards 100. Not exactly 100, approaching towards 100, more than 50%. But if it is exactly same duration, always your answer will be 50%. As in this case it is asked probability of completing the project during expected time period. Here expected time period is 17 weeks. So probability of completing the project within 17 weeks is 50%. How that 50% come, I will explain through problem. Now for probability, if you recall earlier lecture, we have one relationship, capital Z is equal to standard normal deviate is equal to Ts minus Te upon sigma critical path. Sigma critical path, and I have written there sigma critical path is sum of variance of critical activity. Sum of variance of critical activity. Important, sum of variance of critical activity. Now, see here, very important. Critical activities are 1, 3. I will mark here, this 1, 3 is critical activity. 3, 5. 3, 5 is critical activity. And 5, 6. 5, 6 is critical activity. Got it? Now, for this 1-3, if I calculate standard deviation, it is TP minus T1, TP minus TO by 6. So 7 minus 1, 6, 6 by 6, 1, and square of 1, 1. So it is 1. Standard deviation is, variance is 1 for 1-3. For this 3-5, it is 14 minus 2, 14 minus 2, 12. 12 by 6 is 2. Square of 2, 4. 4. For this 15 minus 12, 15 minus 3, 12. 12 by 6, 2. Square of 2, 4. I will explain this. This is a very important point. So what do you get? What we need for that relationship? Now here, since we have finished with this, I will scratch this particular portion for better understanding, because we know these values we have written on activity. What I am trying to explain is further calculation. Now, see here, we know Z is equal to Ts minus Te by sigma critical path, that we have written, and sigma Cp is equal to, it is under root of summation of variance of critical activity. Now, here I have written, calculated that. Let's again calculate how it comes. See, your critical activities are 1-3. If you recall our earlier formula, variance is Tp minus To by 6 whole square. That is the formula for variance for any activity. I am using the same formula. Do not get confused. For 1-3, Tp is 7 minus To 1, 6 by 6, 1 square, 1. Other critical activity is 6, 3, 5. 14 is Tp. 14 minus To is 2. 14 minus to 12, 12 by 6 to 2 square 4 plus 4. 5, 6, TP is 15, 15 minus TO 3, 15 minus 3 12, 12 divided by 6 2, 2 square 4. I will rub this, it is not needed now. Explain how we are calculating that value. Now here this will be equal to 3, 4 plus 4 8 plus 1 9, under root 9 is 3. Got it? So means you are ready with value of sigma Cp. Now TE we know it is 17 weeks. Now we want to calculate the value of probability for 3 cases, and those 3 cases are TS 13, TS 21, TS 17. For these 3 cases we wish to calculate the value of probability. So now remember 3 values, because I will be moving to next slide. Remember this formula. Remember we have calculated sigma Cp for this problem as 3. Remember TE is 17, and we will move ahead. So now we are finding solution of subset for the problem 4 and 5. So now again, before that, let see here. We need one table for that. Now here based on that table, let me show whether there is one table. I will explain the nature of the table. Here we will be having, under standard normal deviate table, values of Z. These Z values will be running from 0, 1, 0.1, 0.2, like that, 1, then 1.1, it will run to 2, it will run to 3.5, and then here you will be having sub columns like 0.01, 0.02, 0.03, like that, and we will be having some values over here. So Once we write the formula Z is equal to Ts minus Te upon sigma Cp. In our case, we wish to calculate first Z is equal to, now for Ts equal to 13 weeks, what we can write? 13 minus Ts is 17 upon sigma Cp is 3, so we get minus 4 by 3. It is minus, Z is equal to minus 1.33. So first value which we get is Z equal to minus 1.33. Now these tables are available in a data book for values of Z ranging from 0 to 3.5 and 0 to minus 3.5. If we don't have the value table for values of 0 to minus 3.5, we know the mathematical concept f of minus t is equal to 1 minus f of t, so that we can simply calculate the value of this Z from the table of 0 to 3.5. Now here, whatever value is given here, whatever entire values given here will be the value of probability. Whatever value is given here will be value of probability. And students, we know that maximum probability is 1. Maximum probability is 1. If we want to quote in percentage, it is 100%. Maximum probability is 1, that we know. But if we want to quote in percent, it is in 100%. And suppose the value is like this. I am giving this for understanding purpose. We will actually see how to locate values from real authentic data sheet. Suppose here it is arbitrarily I am writing, here it is 0.92. What as an interpreter we should do? How to read this data? Calculate the value of Z. Now here, for this sake, you are getting minus 1.33. If you put other case, in other case it will be 21 minus 17 will be again 4. So in next case, this is for first case, for second case you will get Z equal to 21 minus 17, 4, positive 4. So positive 4 by 3 is 1.33. So Z is 1.33. Now suppose I get Z as 1.33. So what I will do, here I am having the column value of 1.3 under Z. Here there are subdivisions like 0.01, 0.02, 0.03. Suppose we are taking for this 1.33. So identify row of 1.3. This is 1.3. Now you note 0.03. So difference 1.3 plus 0.03 is 1.33. How to read table, that I am telling. So now once you identify that row of 1.3, go to the column of that difference of 0.3. Look to this column, search the value which is intersection of this. Suppose by chance the value is, suppose it is written 0.91. So I will read this value for z equal to 1.33 as row 1.3, corresponding column of difference 0.03, value at intersection of this row and column 0.91. I will convert this into percentage and my answer will be, this arbitrarily I am telling, 91%. We'll see what is the actual value in next lecture, but how to read that I am telling. Similarly, we can find the value of other values. And one concept is there. This is how to find probability. We were given the value of probability. You were asked to find the TS for 94% probability in this particular problem. So what we will do, we will locate 0.94 in this map, in this data sheet. We will locate that 0.94. For 0.94 we will find corresponding row and column, and then we will add that row and column. We will find Z. We will go in reverse direction. If probability is given, we will find, we are asked to find TS. From 94% probability, first we will find Z. We will put value of Z over here. We know sigma critical path. We know this TE. From this quantity, only this is unknown, and in that way we will find the value of TS. So today I am ending this problem at this point of time. In next lecture I will show you actual normal distribution data sheet, and I will end this problem by finding the value of probability for respective value of Z. Till then, practice the problems pertaining to drawing network, doing forward and backward calculation, and finding critical path. Practice this much so that you will be in a better position. So here I am ending today's lecture.